Hi, boys and girls. Welcome back to Mr. Cedarbach's geometry class. Here's what we were working on today. So go ahead and open up your ebook to this lesson. Feel free to pause the video if you need some time to get there. And don't forget to take out your pencil and paper and write down today's lesson target. Feel free to pause the video if you need a second to get those out and to copy it down. What, you think it's weird to wear a bike helmet with a shirt and tie? Whatever. Let's get started. Before we begin today's lesson, I'd like to take a look at the Chapter 7 toolkit, specifically regarding parallelograms. So go ahead and take out that toolkit or turn to your notes where you write these things. When you do so, draw the two diagonals of your parallelogram using a ruler or a straight edge. A straight edge is anything with a straight edge, like a note card, an ID card, a pencil, something that helps you draw straight lines. So we're now going to follow the explore, conjecture, prove process to identify properties of the diagonals of a parallelogram. So I'd like you to explore those and make a conjecture, some hypothesis regarding the lengths of the diagonals of a parallelogram, specifically given that they intersect. What happens when they intersect? Okay, so conjecture, and then you're actually going to prove it by using your ruler or your straight edge to measure them to prove or disprove your conjecture. Go ahead and do so, hit pause, and then play when you think you have it. So hopefully you saw that where those diagonals intersect, they also cut each other in half. So I can add 1, 2, 3 tick marks here and 1, 2, 3 here because those two segments are congruent. And then for this one, I will add 1, 2, 3, 4 and 1, 2, 3, 4. What is that word when something cuts something else in half in geometry? Bisect. So if a shape is a parallelogram, then diagonals bisect each other. Now remember, a rectangle and a rhombus are both types of parallelograms. So that means that that property is true for both of those as well. Now let's continue on with this lesson. Lesson 7.2.4. What else can I prove? More properties of quadrilaterals. You know what to do. Hit pause, read through the lesson introduction and problem 7-82, and then hit play. So as you read, this problem is meant to be completed with a team of students. Now you're watching this video most likely by yourself, so that's why you only see letter C below. The rest of the problems, hopefully you can complete with other students through checking in with your teacher. So as we begin, if you have not done so yet, read letter C, hit pause, and then play. All right, to begin this problem, I would like you to copy down the rectangle if you have not yet, and then copy this down here, given and prove. This is how most proofs are presented. You'll see them this way on tests, in other textbooks. This is a standard way to present a proof. So what is given to us? Well, in this case, I'm going to help you out with that. What's given is that ABCD is a rectangle. And what we're trying to prove is that diagonals are congruent. So that is, segment AC is congruent to segment BD. Okay, I'm going to change that. It's going to bug me. Better. So take a moment, and before we start writing our flow chart, try to plan it out. How are you going to prove that those two diagonals are congruent? Now, one hint, what we've been using to prove things about shapes before now is by first proving that triangles are congruent. So see if you can figure out which two triangles by proving they're congruent, you would be able to then conclude that those two segments are congruent. Hit pause and take a moment to think about that and give it a shot. So there are a number of triangles we can use in this problem, but some will require more work than others. So let's try to find two that require less work and still get the job done. So for segment AC, I would suggest using, for example, triangle ADC. And then for segment ED, let's use triangle. Let's see if I can do this over here. BDC. Okay, can I prove those two triangles are congruent? That is our first task. Go ahead and try and prove those triangles are congruent using what is given, that ABCD is a rectangle. Okay, you'll arrange your work in a flow chart. Hit pause and then play when you think you have it. So here's the start to my flow chart. And as you see, we wrote the given, if ABCD is a rectangle, then angle D is congruent to angle C. So we need to provide justification for that. Why was I able to say that angle D here was congruent to angle C here? We're going to put definition of a rectangle. Now you really could put a step in between these because the definition of a rectangle is that D and C are right angles. And then another bubble showing, well, then they're congruent because all right angles are congruent. We're not going to put all that here. We're just going to leave it like this. But if your teacher wants to expand that and to explain it more, they can do so when you check in with them. Now, what else do we know because it's a rectangle? If it's a rectangle, we can then say side AD is congruent to side BC. Why are we allowed to say that? Take a moment and see if you can figure out what our justification would be. If you put properties of a rectangle, that works, or you could put opposite sides of a rectangle are congruent. That's one of the properties of a rectangle. Now, is that enough to prove that the two triangles are congruent? Not yet. What is a third bubble that we can add to prove that these two triangles are congruent? Take a moment, think about it, and then come back when you're ready. Hopefully you saw that this side here is congruent to itself. So we could put DC is congruent to DC. Reason, reflexive property. Or you could have written shared side. Now we have enough information to say, well, if this, and this, then triangles are congruent by what? So let's write our triangle congruence statement. Triangle ADC is congruent to triangle, why don't you go ahead and hit pause and finish this bubble and the justification on the outside. Hit play when you think you have it. Remember, triangle congruent statements have to be written in order of corresponding parts. And so A corresponds with B, D corresponds with C, and so forth, C with D. So triangle BCD. And our reason, side, angle, side, congruence. Okay, now we have proven that the triangles are congruent. But have we proven what we're trying to prove up here? Not yet. So how can we prove from this that AC is congruent to BD? We are going to extend our flow chart. Hit pause, try to extend it to prove that AC and BD are congruent. Come back when you think you're ready. So hopefully you were able to look back at some previous problems and see that when we prove that triangles are congruent, we can then say that all of their corresponding parts are congruent. So are those two segments, AC and BD, corresponding? Well, let's look at the statement above. AC and BD. We can see that since they are in corresponding places in that statement, that tells us that they are corresponding. And since the triangles are congruent, corresponding parts are congruent. So our reason, we'll write it again like this: congruent triangles, congruent parts. Let's go ahead and add this to our toolkit now. Now remember, a rectangle is a special type of parallelogram, which means all of these properties up above are true for a rectangle as well. So let's add those. Opposite sides are congruent. We have not added that yet. There. And then diagonals bisect each other. So let's draw the two diagonals, but don't put any tick marks just yet. So they bisect each other, which means they cut each other in half. But as we just proved, diagonals of a rectangle are also congruent. So when we put our tick marks, we can put 3 here and 3 here. Now for a rectangle, we would put 4 and 4 on the other diagonal. But in this case, since they're congruent, we're going to put 3 and 3 again. They're congruent and they bisect each other.